Hello, everybody. Good morning and welcome. We are so excited to have you for our next edition of one of our Science of SpongeBob programs. Today, we're so excited to meet SpongeBob and Squidward's, among other characters of SpongeBob SquarePants, extended family and imagine prehistoric Bikini Bottom through our museum collections. So together, we're going to explore examples of marine communities extending more than 500 million years in the past. And some of our friends from the museum, who we'll meet more in a moment, will help us go back in time to imagine what a prehistoric Bikini Bottom might have looked like. So together, we're going to discover the ever-changing cast of prehistoric characters and dive into their ancient environments. My name is Rachel Fiddler, and I'm the manager of school and teacher programs and a big SpongeBob fan. I'm joined today by our curator of invertebrate paleontology, Dr. Austin Hendy, who you'll be hearing more from in a moment. We'll be together for about 20 minutes and learn more about how some of our favorite friends from Bikini Bottom have shown up in the fossil record. So today we're going to meet more of your museum, the Natural History Museum, for 35 million objects and specimens, which our staff use in their research, in our exhibitions, or in our programs. And together, their work help us learn more and share about the history of life on our planet. So I'll go ahead and turn it over to our friend, Dr. Austin Hendy, to tell us more about ancient Bikini Bottom and introduce us to the cast of characters that we are oh so familiar with on SpongeBob SquarePants. Hi, Dr. Hendy.
Good morning. How are you doing?
Doing well. Excited to be here.
All right. Well, as fate would have it, as soon as we start this webinar, I get a message saying my internet is unstable. So please excuse me if I lose you for a little bit, I sound patchy, let me know, and I'll try and repeat what I've said, or we'll figure it out. Anyway, I'm a paleontologist. I study fossils. These are the remains of organisms that were once alive, both in our oceans and on land. They could have skeletons. They could be soft-bodied creatures. They could even be the traces of fossils or of organisms that were once living, either interacting with the environment or interacting with other organisms. As a paleontologist, there are two ways I could approach what ancient Bikini Bottom looked like. First, we could look at the cast of characters. Who was living in Bikini Bottom? And what do we know about their fossil record around the world? So I thought that would be a good place to start. When in the history of Bikini Bottom do we first see many of these characters? So Jessica, you can go to the next slide. All right, so essentially we're looking at the Bikini Bottom archives. This is what museums around the world provide us with. Essentially, it's the equivalent of all of those rolls of film, those film canisters from past episodes. And I liken that archive, the geological record to such an archive. So on the right-hand side, we don't have too much time to get into the geological timescale, but this is a representation of the geological timescale that paleontologists like myself use. And you'll see all these names on the right-hand side: the Cambrian, the Ordovician, the Silurian. These are time periods that paleontologists will use to classify the fossils that we find, from oldest at the bottom to youngest at the top. Particularly today, I want you to pay attention to the Cambrian and the Ordovician. These are around 540 to 450 million years ago. And this is a time period when many of the organisms we see in our oceans today first evolved. Of course, they looked very different back then, but it was a time of tremendous evolution and proliferation of life, both many species, but also many different forms, ways of organisms interacting in the marine environment. All right, next slide, please. All right, so first, the main character, SpongeBob. He actually has quite a good history in the fossil record. Sponges, believe it or not, were among the first complex organisms to show up in the fossil record. We don't think of sponges as being particularly complex, but when they first arrived around 600 million years ago is when we have our first evidence. They were by far the most advanced organisms that there were living on the seafloor. And in fact, it's thought that sponges, along with some other organisms like the earliest worms, created the first mass extinction by being so good at doing what they do, filter feeding the water and reproducing and covering the seafloor, that they crowded out many of the other more primitive organisms. So we have evidence of sponges from chemicals that they produce and they leave in the sediment. We also have a range of fossils,
Austin,
some that look like modern.
Your sound is a little bit past.
Okay, I'm gonna. Is that any better? Rachel, does that sound better, my sound?
Sorry about that. I think we had a little bit of a glitch.
No.
Are you back up, Austin?
I am here. Can you hear me, Rachel?
I can, yeah, you seem to be good. Sorry about that.
I'm so sorry. So we have a range of sponge fossils. These could be microscopic. So for example, this beautiful image in the top right-hand corner, this is only about a centimeter in size, but looks very much like a modern sponge. But we also have the components of sponges. Sponges, they're not, if you've seen them washing up on the beach or in the tide pools, they're not particularly resilient organisms. They break down very quickly after death. And what they turn into are sponge spicules. So Jessica, could you advance for a second? Just click forward, yeah. So the top right-hand corner are modern sponge spicules. They're made of silica. And these actually do preserve very well, but they're incredibly small. They're about 1 millimeter in size. So if we look under a microscope, we can actually see evidence of sponges in many sediments from around the world. Okay, next slide. So SpongeBob has been with us and his friends for 600 million years or so. What about Patrick? Well, Patrick's a little bit younger. The first sea stars appeared around 450 million years ago. This is a time period that we call the Ordovician. And like sponges, they don't preserve so well. There's a spectacular specimen I'm showing you here on the left-hand side. That's a sea star from Germany. That's Jurassic in age, so about 150 million years old. But sea stars and brittle stars are made up of little calcium carbonate building blocks. We call them ossicles, and they're held together by tissue. Upon death of the sea star, they typically break apart very quickly. So you have to bury those sea stars very quickly, keep them away from any organisms that are burrowing or consuming them in order to get them preserved. So you see a few examples. There's a ray fragment in the top right-hand corner, and then an example in the bottom right-hand corner of those ossicles just starting to fall apart. And again, if we look under a microscope at sediment, we'll often see individual white grains that were sea stars originally, but have now broken apart into millions and millions of pieces. I'm not sure if you can see my camera, but here are some fossils from our collection of sea stars. When we find them, we can find them in very large numbers, presumably because we had the environmental conditions that were just right to bury them quickly and preserve them. All right, let's go on to the next slide. Well, this is the group that I work on. I work on snails, and snails have been around for 500 million years, so back to the Cambrian period. But the earliest snails weren't particularly recognizable. They don't look like Gary. So the photo on the left are probably our earliest snails that we can be sure of. A lot of scientists argue about other fossils that we have, but certainly by about 450 million years ago, on the right-hand side, we had quite a diversity of snails. And in fact, I have some slabs of rock somewhere around me. Oh, here's one right here, actually. This is a slab of Ordovician rock, pretty hard to see in my little camera here, but there are a lot of little snails all over it. There's one here right by my finger. Yep. So within about 50 million years, they become quite an important part of fossil ecosystems. All right, let's see what we've got next. Ah, crabs. Crabs are fun. Mr. Krabs, he has relatives that go back to the Jurassic, about 180 million years ago. They have a pretty good fossil record, even though they're relatively fragile. Typically, what we see from crabs is a lot of bits and pieces preserved in the fossil record. Their pincers, for instance, and their legs can be quite hard, quite resilient, and they tend to get preserved. But the ornate carapace, the shell of the crab, tends to get broken up. The photo on the right-hand side is a really exceptionally preserved specimen from Colombia that actually has big, giant eyeballs that got preserved, all of its legs attached. Whenever we find fossils like these, they are so important for reconstructing the family tree of crabs and any other organism, for instance. So if we proceed to the next picture, Jessica, this is very small, but it is a family tree of all of the crabs. And what we can see with this, if you're able to zoom in, is that almost all of the modern representatives of crabs, the ones that we recognize today, both in the intertidal, the tide pools, the beaches, and down to the deep sea, they all show up in the fossil record around the Jurassic to Cretaceous, so around 150 to 120 million years ago. So all of these different creatures that we recognize in Bikini Bottom, they show up at different times, and crabs are one of the later ones. Okay, let's see who we got next. Cephalopods. All right. So this is Squidward tentacles, and a bit of a problem. Doesn't really look like a squid, and he's not a squid. Apparently, he's an octopus. We can tell that because of his big head. Octopus have a very large head and quite big eyes, but he has only got 4 tentacles, which is the problem. Octopus have 8 tentacles, but because we know that he is an octopus, he is a cephalopod. It's a class of mollusks like gastropods and bivalves. The earliest cephalopods show up in the Cambrian about 510 million years ago. And there's a picture, a reconstruction of one in the middle there. It's called Plectronoceros. It was essentially like a snail crawling on the seafloor, so not swimming like modern cephalopods do. On the right-hand side are a few examples of different kinds of fossil cephalopods. So we've got Ammonites, and here's one I have right next to me. I love Ammonites, amazing, amazing fossils, and we find them all around the world. We also have Nautiloids, and you'll see the bottom right-hand side picture there. It's called Orthoceras. These things could get up to 30 feet long. And I have one on the floor here. Hold on. All right. I can't actually zoom in too close because it'll fill up the camera. But this one is about 2.5 feet long, so it's not quite the giant that it could be. But this is a nautiloid. Now, you may recognize that name. Here is a modern nautilus, right? They live in the today. Primitive nautiloids were straight. So they have changed quite a bit over the years. Let's see what we've got next. Can we advance, Jessica? Yeah, there we go. Okay, so Squidward, we know he's an octopus, and unlike Ammonites and the Nautilus, these are other cephalopods, octopus and squid are entirely soft-bodied. So they don't have any hard parts that preserve well on the fossil record, other than perhaps their beak, their mouth parts that they use for consuming prey. So we have very, very few fossils of octopods. And I show a couple photos on the right-hand side of some of the more spectacular specimens, but they are very, very rare in the fossil record. So we don't know too much about Squidward tentacles family. Okay, let's see what else we have, Jessica. Okay, so I'm taking a little bit of liberty here, and we're looking at the Bikini Bottom game and trying to find a few more creatures. Most of the characters in SpongeBob are fish, other than the ones that I've just shown you. About if we're looking at the game, we can actually see a few other critters, organisms. We have seaweed, and seaweed has or algae in general has a very long fossil record. Here's one example that goes back 515 million years or so, but potentially they go back closer to 600 million years. What else we got? Next slide. Sea urchins. So there's a spectacular, what's called a sideroid urchin on the right-hand side here. They go back as far as the Ordovician, so around 450 million years ago. And here's one that looks actually very similar to the photo in the slide from our collection. It's called Archaeosidaris. And these have, if you have a close-up view at the spines, see the spines are very prickly. So those spines presumably are for protection from predators. All right. Who is next? Sea anemones. Now, sea anemones, again, to continue the theme, are not well preserved in the fossil record. And again, it's because they're soft-bodied. They don't leave hard parts. So basically, if we're looking for a fossil sponge, we're probably looking for an impression or a smudge in the rocks. And so there are very, very few examples of them. One of the oldest is this one called Mackenzia. It's from Canada, and it's around 515 million years old. But these are exceptionally rare. I don't believe we have any in our collection here at the museum. Okay, what's next? All right, so another way to examine what ancient Bikini Bottom looked like is to go back in time. I think of myself as a time-traveling marine biologist. And the museum collection is a wonderful place to do that. Also the field, going out and looking at rocks is another way we could do that. So let's go to the next slide, Jessica, see what we have. And so one thing we can do with all of those collections of fossils that we have for one place, and I'll show you an example of one. There's a slab of fossils right here, lots of different kinds. All right, we know that all of these things lived at exactly the same time on the seafloor. They were interacting. They were an ecosystem. And we have lots of different slabs that look like this. There's another one. Not much light. All right, lots of fossils living together and presumably interacting with one another and the environment. And scientists will put those together to try and reconstruct that ecosystem. Who was eating who was growing high into the water, who was burrowing into the muds. So I grew up reading a book. These pictures are out of, just fascinated by this, the ecology of fossils, and trying to bring what are essentially dead organisms, embedded or turned to rock, bring them back to life and understand how they interact with one another. And that's kind of what I do now as a job. Next slide. All right, well, this is fun. We're gonna stop listening to me for a few seconds and actually watch some SpongeBob and see what we can learn. Jessica, you can go to the next slide, the link.
Well, I wouldn't have chosen this interior. Oh, what's this? Well, if SpongeBob exists in the future, I'd better go to the past. Wow, primitive. That's sort of an old world charm. Wow. I guess this is before manners were invented. Well, at least there's no sign of Sponge Brat. Maybe now I can finally be alone with my clarinet. Huh? What? Huh?
Oh, that was great. Okay, we can proceed to the next slide. So Squidward does go back in time in one episode in a vain attempt to escape his friends, SpongeBob and Patrick. And it's kind of fun. We get to see some of the creatures that the inventors of SpongeBob came up with. And I've been looking at this a few times, trying to figure out when in time this is. But we can certainly look at some of the critters that were around. So we have sea lilies, which are, we call them crinoids. And these aren't plants. They are actually echinoderms. They're related to sea urchins and sea stars that grew on stalks. Think of them as an upside down sea star. They grew on stalks and they stuck up into the water and they filter feeded food out of the water column. There are a couple fossils right here. Very pretty. And so we're looking at the very top of them, and their arms got lots of little hairs on them that they would use to catch particles in the water and then pass them down into their mouth. We also have some kind of cephalopods swimming across the screen. And as a paleontologist, I'm always looking for features that tell me what kind of animal this is. Don't know whether it's a nautilus or an ammonoid. But one thing I do notice is they have this swimming upside down. So typically, the opening of the ammonite will be on the bottom when it's swimming, right? With the tentacles coming out the bottom. They actually, if you look at the coiling of that specimen, they have it swimming. I'm not very good at this, swimming like that. You know what? How about I use my trusty kid's toy? They actually have it swimming upside down, which would make it a very unhappy ammonoid. So that's pretty cool. Sea lilies have been around nearly 500 million years, and coiled ammonites or nautiloids like that, a little bit younger. So yeah, we're a couple 100 million years old at the very least. Next slide, let's see what else we have in that little episode. We have sea anemones, don't preserve well in the fossil records, so very few of those, as I mentioned earlier, but there were trilobites, which are cool. I think they could have shown us more trilobites. And we have a lot of those in our collection. So here's an example of one right here. This is called Isotelus. It's just a baby, all right? Looks kind of big next to me, but it's a baby. They could get up to 3 feet long. And so this is an outline of one based on the largest ever one found, which I think are pretty cool. I could imagine SpongeBob, if he ever gives up jellyfishing, could look into surfing on trilobites, skating on trilobites. Okay, what else we got? Let's go to the next slide. Okay, in the far distance, I'm really scratching the barrel here. The far distance, we have some corals growing on a rock. Corals have an exceptionally long fossil record. Here's some right here. These are rugose corals, which I believe is what is in the picture. They look like little horns growing up, and they would have had tentacles coming up the top there. And we call them solitary corals, but they would often grow in little reefs together, little communities on the seafloor. Would have been very pretty. There is something else that's swimming across the picture there. I'm guessing that the inventors of SpongeBob based this on the Cambrian time period, when there was a lot of evolution and a lot of novel forms. And some of the organisms we think of today as being relatively primitive, like worms, for instance, were actually really important in the ecosystem back then and could get quite big. There were no major large predators. And so this is probably some kind of worm that's swimming through the water column. Today, these kinds of organisms are restricted to living in or on the sediment. Back then, there were no fish. And so they could exploit that environment. Okay, what else we got, Jessica? Okay, that is actually the end of the presentation. But what I do want to say is we're open again at the Natural History Museum, and you are welcome to travel back in time with me in the exhibits. We have the wonderful dinosaur hall, where you can look at not only dinosaurs, but marine reptiles and some of the organisms that they lived with. And we're building a new exhibit. It's called Los Angeles Underwater. And that is going to be opening up March of 2022. And it'll be an opportunity for you to explore the geology and the paleontology of Los Angeles through the many fossil discoveries that were made in the city. We have fossils all around us, often underneath the roads and the buildings of our city. But you can still find them today in the hills around the city, the Santa Monica Mountains, the Palos Verdes Hills. There's a lot to discover outside around our city. So thank you for joining me today. This has been wonderful. And I look forward to seeing you at the museum.
Thank you so much, Dr. Hendy. It was so fun going back in time and learning a little bit more about all of these casts of characters. We have some questions from students, so we can take kind of the next 5 minutes and answer some of those dying questions we're dying to know more about. So Jacob from Instagram was wondering, how old would Gary need to be in order to become a fossil?
Okay, yeah, it's a very good question. So fossils are preserved in many different ways, and sometimes the oldest fossils can look absolutely spectacular, like a shell that just washed up on the beach yesterday. Other times they can be just shells could be a few hundred years old and look absolutely crummy. So scientists tend not to think about the preservation, but their age. And we have a technical definition that a fossil is something that is older than 10,000 years old. Keeps it nice and simple.
That makes sense. Very cool. Angela was wondering, can you tell us more about Ammonites and their role in the prehistoric Bikini Bottom ecosystem?
Yeah. So Ammonites are fun organisms. I love them. Extremely diverse. There are thousands of species of Ammonites, and they all come in different shapes and sizes. So if we were to roll back the episodes of Bikini Bottom to the Jurassic or the Cretaceous, so let's say around 100 million years ago, there would be many species of these Ammonites swimming around in the water. They would have been more important than fish are today in the ecosystem. So we think when we go diving or swimming, there'll be a lot of fish in the water. They are the primary predators, including large fish like sharks. But we go back further in time, then cephalopods like ammonites were the most important organism in the water. Some of them were living down the seafloor, probably chasing around the earliest crabs and lobsters and giving them quite a fright. Others would be chasing around some of the earliest fish in the water column. They came in different shapes. Some were very skinny and designed for speed. Others were quite chunky and designed to be strong, right? So you can either outrun your competition, or you can be stronger than them. And ammonites utilized both of those.
So cool. Stephanie and Carla are curious, how did you get those fossils that you're showing us?
That's a very good question. Well, the museum is here for perpetuity. We're here forever, and it opened in 1913. So we have been growing our collections since then. So many people have contributed to the museum's collection. We have over 7 million specimens. So I just grabbed a few of them today. I'm gonna have to put them away in a few minutes. Of those 7 million specimens to show you today. But they come from scientists like myself collecting. They come from folks like you who make discoveries and donate them to the museum. Yeah.
That is so neat. Thanks for showing us those today. That has been so cool. Abigail and Stephanie were curious, what is the oldest fossil that you have in the collection?
Let's see, do I have one with me? I'm looking. Gosh, I have to walk back and let's do it. We'll walk back in the collection and see if we can find one for you. So the oldest fossils that we have in our collection are about 3.4 billion years old. So that's a lot older than anything that I've shown you. And that does sound the coolest in a way. All right, here we go. So by the way, we just walked through the collection and we have row after row of cabinet. And I've been put away. So the oldest fossils are of and algae. Warm. Here we go. All right. And they're not particularly exciting organisms to look at, but what they did in the absence of any other animals is, sorry, my internet is unstable. They held down the seafloor. They grew algal mats and bacterial mats across the seafloor. So think of, maybe you've walked across a pond that's drying up and there's like green scum growing across it, a really rich soup of algae and bacteria. And that would be holding down the mud on the seafloor. Over time, these layers of bacteria grow on top of the mud and hold it down, and eventually it cements, and these are called stromatolites. And all this time they're photosynthesizing, so generating oxygen, which ultimately allows for all the rest of this life to proliferate. So this particular specimen is about 1 billion years old. I'm not sure where the 3 billion year old specimen is. It's been put away, as it should, in a museum. But this is from California. This is from close to the Nevada border, Inyo County. And yeah, it records a very important time in Earth history when oxygen was being generated, which we all need today.
Wow, that was so fun. I loved the behind the scenes of the collections too. We don't get to go back there too often. That was super special. Okay, we have time for maybe 2 more questions. Alina was curious, how do you know how old the fossils are?
Very good question. And I wish I had more time to get into that. So typically in a job like mine, we don't directly date the fossils. If we're trying to understand the geology of the local area, we're going to look for rocks that we can date. And these are often volcanic rocks. Igneous rocks, volcanic rocks contain a lot of radiogenic isotopes in them. So these are elements that are unstable and undergoing decay, and it provides us with a very precise measurement of how old they are. So we can look at we know how fast these elements are decaying, these isotopes are decaying. That is known, that can be tested experimentally. So we're looking for the ratios of different isotopes, and that gives us a very precise age, but not of the fossils, of the sediments that the fossils are either in or sandwiched by. And if we do that enough times around the world, and there is a wealth of that data, we can then say that we always see the species of Ammonite between these 2 ages. This particular specimen is about 90 million years old. No one has actually dated the physical fossil to get that number, but we know this is from Wyoming. We know that there's lots of ash beds in the middle of the country that were deposited around that time, and that has given us the age. So whenever we find a fossil that looks like this, we say it's late Cretaceous, around 90 million years old. That's it in a 1-minute nutshell.
The elevator pitch for how you date fossils.
Yeah.
Very cool. Okay, our final question, which may be our hardest question that you've had this whole presentation. Carla is wondering, what is your favorite fossil?
Oh gosh, that's a good question. I should have thought about that. Okay, I'm going to limit it to the ones on the table in front of me, and I think some of the coolest are the Trilobites, and I love them just because, I mean, they're neat little organisms, right? They're arthropods, like insects are, much more primitive. And they kind of have personality. So this is one that, when they get frightened, they would roll up, just like an armadillo or a pill bug does. And so we often find them rolled up. But look at it, it's got a little face. It's kind of cute, rolled up there. And they could actually roll all the way up and lock, just like Tupperware does. All right, so this, oh, I'm holding it upside down. Here's the head and the bottom, they're locked together. And if you can just zoom in, focus this, They've got these big eyes with thousands and thousands of little lenses on them. So these trilobites were, they were the innovators. They were experimenting on developing vision many different ways, many different times. So very important creatures. Most of them don't get as big as this guy that I showed earlier, but they were very important in the ecosystem for several 100 million years. They go extinct about 250 million years ago, which is a great shame because I think they're pretty awesome.
I agree. They're super awesome. And I think we could have seen more of those in that episode where Squidward went back in time. That would have been so much fun.
Absolutely. Yep.
Well, thank you, Dr. Hendy. It's been so fun getting to know SpongeBob's ancient ancestors. And we thank you for taking us behind the scenes into the collection space. It's been a pleasure. We'll see you next time.
Thank you so much, everyone. We'll see you at the museum.
I'm going to go ahead and just close us out of our program today. I want to start by thanking our amazing partner, Nickelodeon, for helping us put on these super fun Science of SpongeBob related programs. Don't forget, you can join us every Tuesday and Thursday of this month to continue learning about our friends in Bikini Bottom and the Science of SpongeBob. So to see activities and our full schedule of programming, you can visit nhm.org/SpongeBob. Thanks, everybody. We'll see you next time. Have a great day.